Hey students, this is lesson 511, and we're going to learn how to simplify algebraic expressions. In today's lessons, we're going to use geometric models to do that. I'm going to let you do the elephant stuff on your own there, read that, check out what our objectives are for this lesson. And we're going to start right here on, and you can do this think and discuss on your own. We're going to start right here at investigation 1. And the idea here is we're going to use geometric models to try and figure out how to simplify expressions when you're multiplying a variable by itself. All right, so check out this here diagram. We have a rectangle, and the height of the rectangle is x, as you can see right there. And the length of the rectangle is x and then 3 more than that. So you'll notice we can just write that as x plus 3. Okay, it says one of the rectangles in this diagram has an area of x times the quantity x plus 3. Remember, area of a rectangle is length times width. So what they did is they took the length, which is x plus 3, and they multiplied it by the width x. Okay, so we want to indicate that. And all we need to do to show that is that we are multiplying this by this total length. So I'm just going to shade that what we have is one great big rectangle here, which includes this added on part. So we're multiplying this length times this width. All right. Okay, and then it says use your diagram to expand the expression. From the diagram, you probably noticed that we had really 2 parts there. We had a square part and then the extra piece added on. So we can talk about the area as those 2 pieces added together. The dimensions, the height of the rectangle is x, and then that's a square, so that side's x also. That dimension is 3 and that dimension is x. So now think about the area of this square. What we can do is just multiply length times width there. They're both x, so that's x times x, or the part I shaded, we can just write as x second. And then this part right here, we can write that as, use a different color, and then we can see the 2 different parts in our expression. So that is length times width, 3 times x. All right, and the picture explains what we did there. We just separated it into 2 parts. Okay, now Dante and Hector are making another rectangle diagram. If you look at what Dante's doing, he says start with a square. So, and I'll draw it over here again. So we're going to start with the square. I'll try and draw a nice perfect square for you. Okay, there's a square. All right, and he says cut off 3 centimeters for one side. Before I do that, I'm going to label. So this side is x, and this whole length is x. Now I'm going to cut off 3 centimeters. So I'm going to use a dotted line to show the part I'm cutting off here. Chop that off, taking away 3. Now remember, this whole distance from here all the way to here is x. And now we can use x to describe the area of the remaining rectangle. What we'll do is, we know we took out 3 here, so that this little piece from here to here is x minus 3. And so the area of the part that we're left with, which I'll shade here, that part there is the length times the width. The length is x minus 3, and the width is x, so we can write that area as x times quantity x minus 3. Okay, now Dante says, I think there's 2 expressions for that area, and there is. And if you think about this, think about what we started with, and I'll just draw what Dante's saying there. We started with the square, and then we took a piece off of that square. So we have a square, and then we have a little piece that we subtracted off. So, like that. And so I'm going to put a minus sign in between because we subtracted that. And the dimensions of the piece we subtracted are 3 and x. The dimensions of the piece we started with are x and x. And if you think about the area of the square, that's just x squared. And the area of the piece that we're subtracting off is 3x. And so we can write an expression as x squared minus 3x. All right. So the next problem is another one like that where you're taking part of it off. We're going to do that one in class. I'm going to skip to we'll do the number 4 in class. I'm going to do number 5. So number 5, it's a little bigger problem here. All right. So notice that we start with a square with side length x right here. And we create a large rectangle by adding another square the same size and then add a little square of 1 onto the end. As you look at that, the height of this great big long rectangle here is exactly the same as the height of this little square, which is x. Okay? All right, so that height is x. All right, now, and let's go back here and look at one other thing here. You'll notice on that rectangle that, check out this long piece right here. We have 2 x's and a 1 that create the length of that. So we can call the entire length x plus 1. Or we could simplify that to 2x plus 1. So our width is x plus 1. And I think some of you are thinking x plus x is x squared, but no, that's x times x. X plus x is 2x plus 1. Okay? Now it says use the dimensions from part A and B to write an expression. We want area is equal to the base times the height. Or the width times the height, in this case. And if we do that, the height we had was x, the width we had is 2x plus 1, and multiplying that expression is what we get. Okay, now you'll notice that the large rectangle is composed of 2 squares and a smaller rectangle, and we want to write an expression for the area of each of these parts. So we have 2 squares, and I'll put it like this, square, 1 more square just like that, and I'm going to separate them apart so we can see that they're really separate little areas, and then a little rectangle strip that was on the end, like that. And so I have 3 parts, and we can talk about the area individually. Now remember that the height of those were x, and the width of those are x. Same with this one, x. This width was 1, and that height is 1. So if we talk about the area inside those, we have x times x, which is x to the second, x times x, which is x to the second, and 1 times x, which is x. And if we just add those 3 together, we get the total area. So we get x squared plus x squared plus 1x. Okay? And we can simplify that. X squared plus x squared is the same as 2x squared. Not x to the 4th. X to the 4th would be x squared times x squared. And so now, since we both represent the same area, both of those, we can say that our first expression, x times quantity 2x plus 1, is equal to our second expression, 2x squared plus x. Okay, now if we remember the distributive property, that just means we're multiplying the number outside the parentheses by each of the things inside. So if we do that, we need to do x times 2x And then we also need to do x times 1. And x times 2x is the same as 2x to the second, and x times 1 is the same as x. So we're just showing that we could have just used the distributive property to do that. All right, so let's do number 6 here. A little bit different, where we're actually subtracting off a part. All right, it says start with square side x and another square the same size and remove a strip of width 1. Okay. Use a diagram to help explain why x times quantity 2x minus 1 equals 2x squared minus x. Okay, so if we think about this first rectangle right here, the whole thing, the height is x, and the width is 1. There's an x there, there's another x there, but then we're taking off that, so the amount we're left with right there, and I'll do that in red, is the height, which is x, times the width, which is x plus x minus 1. And we can simplify that a little bit. We can just write 2x minus 1. And that makes sense because we added 2 x's together and then we took 1 away from that. Okay, now if we think about separating that into pieces, we have our 2 original squares. And remember, we cut off this strip off the end of one of those. So if we add the 2 original squares, then we got to subtract that one piece that we cut off. And our dimensions are x by x. Same with the second one, x by x. And the last one is a strip of 1x. And if we find the area inside, we get x squared, another x squared, and minus 1x. And the expression for that is x squared plus x squared, which is 2x squared, minus 1x. All right? And again, we could show the distributive property to get that. If I'm taking this expression right, the expression I have in red there, and distribute it, multiply x times 2x, that's the same as 2x to the second. Multiply x times 1, that's the same as 1x, and I'm subtracting, so it makes sense. All right, that is going to be the end of the lesson, and the rest we're going to do in class. See you tomorrow.